Hi students, in this video I'll be going through the 2020 O-Level Additional Mathematics Paper 1 question 10. Right, so let's read the question. So diagram shows for x greater or equals to 0, less than or equals to pi, the curve y equals to cosine 2x, and the line y equals to negative square root 3 over 2. Okay, the curve and the line intersect at the points A and B. So for part 1, they want us to find the x coordinate of A and of B. Okay, so since A and B are the intersection points of the line and the curve, okay, what we need to do is to solve the equations of the line and the curve simultaneously, and we will be able to find the x coordinates of A and B. Alright, so let's call this equation of the curve equation 1 and the equation of the line equation 2. Okay, so what we are going to do is we are just going to equate equations 1 and 2. Alright, so equate 1 and 2. So equate 1 and 2. Alright, so if we equate 1 and 2, we will have cosine 2x equals to negative square root 3 over 2. Okay, so this is basically just like solving a normal triple equation. What we want to do is we want to find the basic angle, and then after that cosine is negative, so it will be in the second and third quadrant. Okay, we'll find the respective angles in the second and third quadrant. Okay, so we'll let cosine alpha. Okay, so alpha is now the basic angle to be square root 3 over 2, where alpha is the basic angle. Okay, so we know that cosine 30 will give us a square root 3 over 2. Okay, but now we are working in terms of radians. Okay, so we still at the range. So 30 degrees will be pi over 6. So in other words, the basic angle will be pi over 6. All right. Okay, so pi over 6. Okay, so now cosine is negative. So always look at the sign over here. Cosine is negative, right? So negative, we will go for the second and third quadrant. A, S. So S is sign is positive, so cosine will be negative. So T, tangent will be positive. Cosine will be negative. Finally, the fourth quadrant, T, cosine will be positive. So we are going to go for this quadrant and this quadrant. Right, so remember the angle that we are finding now is 2x, so 2x will be equals to, so in the second quadrant, the angle will be pi minus the basic angle, and in the third quadrant, it will be pi plus the basic angle. Okay, so from here, we will get 5 pi over 6, and then here we'll get 7 pi over 6. Okay, so if we divide by 2, okay, we are going to get the two answers. Okay, 5 pi over 12 and then 7 pi over 12. Okay, so which one will be the x coordinate of A? So obviously A is on the left side, right, of B. So it should be the smaller one. Okay, 5 pi over 12. Okay, so let's conclude therefore x coordinate of A will be 5 pi over 12. So, and x coordinate of B will be the 7 pi over 12. Okay, so you can actually check your answer because this point that's in between, okay, it's pi over 2. Pi over 2 will actually be 6 pi over 12, right? Okay, so that means this point, okay, is reasonable for it to be 7 pi over 12. Okay, slightly bigger than 6 pi over 12, and the coordinate of this point to be 5 pi over 12. Okay, so we roughly know that okay, our answer at least makes sense, right? So we can be confident that it's correct. Okay, so let's take a look at part 2 of the question. So they say showing all your working, find the exact area of the shaded region. So the shaded region is over here. Okay, if you look carefully, the shaded region is actually bounded by the line y equals to negative square root over 2 and the curve y equals to cosine 2x. Okay, by this point, you need to ask yourself, is the line on top or the curve on top? So it's quite clear that the line, okay, I'm going to highlight in red, right? Okay, the line is on top of the curve. Okay, so the curve I'm going to use maybe green. Okay, So green, so the curve is below. Okay, so basically if the line is on top and the curve is below, to find the area bounded by the line and the curve, all we need to do is to take the one that's on top, okay, the equation of the line, okay, minus the equation of the curve, and then we integrate from here. Okay, so over here, from A to B, okay, the x coordinate of A to B. So we found earlier to be 5 pi over 12, and then the x coordinate of B we find to be 7 pi over 12. Okay, so we are going to integrate from 5 pi over 12 to 7 pi over 12 for the line is on top of the curve. So equation of line minus equation of curve. Right, so let's go ahead and do that. And you can see that actually it's not that difficult. So it's actually a 6-mark question, okay, but not that difficult to do. Okay, so shaded area. Okay, we are going to integrate, okay, from 5 pi over 12. So the lower bound always at the bottom, upper bound on top. Okay, equation of line minus the equation of the curve. Okay, so the equation of the line is a negative square root 3 over 2 minus the curve cosine 2x. Okay, so we just have to carry out the integration for these two. So integrate negative square root 3 over 2, we'll just get negative square root 3 over 2x. Okay, integrate cosine, we will get a positive sign. Then all we need to do is one more step, differentiate the angle. Okay, we'll get a 2, and then we divide the 2 below. Okay, so we're actually done with the integration already. Okay, so now we just need to put in the values now. Okay. Okay, so this sine 2x over 2, we can also write it as half sine 2x. Okay, so that's the form that I want to use. Okay, so firstly, okay, sub in the 7 pi over 12. So to replace the x, okay, minus sine okay, half sine 2x. Okay, put a half in front. Minus half sine 2 times 7 pi over 12. Okay, then this part put a big bracket. Okay, minus. Okay, I'll make a difference because inside there's negative sign. Okay, 5 pi over 12. Okay, minus half sine 2 times 5 pi over 12. Okay, so just like this. Okay, so we just have to work out the terms one by one. Okay, so over here we will actually get negative 7 square root 3 over 24 pi. Okay, minus half sine. Okay, 2 times 7 pi over 12 becomes 7 pi over 6. Okay, so I'll do an additional step. Okay, this one will open. Negative and negative become positive, right? So it becomes 5 square root 3 over 24 pi. Okay, then negative and negative become plus, so plus half sine 5 pi over 6. Alright. Okay, so this one you may want to put. Okay, then from here, negative 7 root 3 over 24 plus 5 root 3 over 24, you'll end up with negative 2 root 3 over 24 pi. Okay, sine 7 pi over 6, if you calculate out, you'll get negative half. Right, so here negative half. Then over here, okay, sine 5 pi over 6. Okay, use your calculator, you will end up with half. Right? Okay, so from here, we should be able to simplify. Okay, half times half will give you 1/4. So down here will become 1/4, right? Then down here another 1/4. 1/4 plus 1/4 will give you half. Right, so that's where we're going to get the half from, right? Okay, then 2 and 24 becomes root 3 over 12, just root 3 over 12. Okay, so minus root 3 over 12 pi. Okay, unit square. Okay, so over here, if you look at the question, they want the exact area. Okay, so exact area means you do not need to compute this out and leave your answer in 3 ticks. Okay, so you can leave your answer just like this. Okay, so just a recap. So to find the shaded area is bounded by the line on top and the curve below. So you use the equation of the line minus, again, minus the equation of the curve. Okay, why minus? Why line minus curve? Because line is on top of the curve. If the curve is on top of the line, then it will be curve minus line. Okay, so the one that is on top minus the one that is below. Okay, so this is how you solve questions like this regarding the area under, right?